Hi there, this is Dr. John, your physics and math professor, coming to you with another video to introduce the concepts and ideas of trig functions. And this is the second video in this series. Here we're going to try to define the basic trig functions, sine, cosine, and tangent, give you an idea maybe where they came from. So trigonometry is the study of triangles, how to measure triangles. It actually comes from two Greek words, one trigonon, which is this first part, and then metron, which is the second part, which means to measure triangles. And of course, the Greeks were all into shapes and geometry, circles, rectangles, rhombuses, triangles, especially triangles. They had a great love for triangles. I mentioned that in a couple of other videos. And they observed a bunch of different things about triangles. For one, they noticed that there were some things called similar triangles. That's triangles where you just seem to take the entire shape, you squeeze all the sides in a similar way. The angles stay the same on each of the sides. So this angle over here would be the same as this angle over here, would be the same as this one. And this angle over here, I'll mark it with double sticks like that, would be the same as that one over there. It's too tiny to mark that. And the same over here. This one here would be the same as this one here. They found that if you just take the triangle and stretch it, the sides may stretch, but the angles stay the same. And I illustrated that for you with one right over here. This is a very important concept. It's very similar to your televisions. You can watch a show on your small screen, your phone, or on a large screen on the wall. And the reason everything looks in proportion is because the angles, even though the sizes are stretched, the angles stay the same between things. Otherwise, you would have faces distorted and it just wouldn't look right. So here we have an example of this, of two similar triangles. This one inside the small black one, they're both right angle triangles because that's what the Greeks love to do. A lot of trigonometry is based on, at least started off with right angle triangles. We have a triangle with sides 3, 4, and 5. The longest side is always the hypotenuse. It's the side opposite the 90-degree one right here. And then this one here, we've stretched everything. Notice all the sides are doubled. Instead of 4, this is 8. Instead of 3, this is 6. Instead of 5, this is 10. But this angle over here, obviously, this angle over here, whatever I want to call that the angle theta, is the same for both of them. And so the Greeks started to think, okay, is there a way that we can take the sides of a right angle triangle, make some relationship that helps us define these angles, alpha, omega, or theta? So what they did is they said, let's drop triangles and we're going to take a ratio of the different sides of the triangle. I'm going to take a second and just drop a generic triangle over here, a right angle triangle, and we're going to take some of those ratios. Okay, I just took a minute here to drop this right angle triangle. Right angle triangles are shown this way with a little box there to show like it's in the corner of a house. That's 90 degrees. And the other two angles here add up to 90 degrees as well because the inside angles of a triangle all add up to 180 degrees. That doesn't matter if it's a triangle like this, or like this, or like this. Any kind of triangle, all the inside angles will add up to 180 degrees. The Greeks also discovered that. Now, what they did is they said, is there a way we can define this angle, the angle theta, often labeled again with Greek letters, with some sort of ratio of the sides? Well, there's obviously three different ratios, or we can flip them upside down, but three basic ratios here. I've written them out here. The opposite sides, I'll label with an O. The adjacent to this. Now, this one is also adjacent, but this one has a special name. It's the hypotenuse. It's the longest side. So we give that a special name. The other one we call the adjacent. And what we can do is we can create some labels for those. And let's say let's take the opposite over the hypotenuse. I'm going to call that O over H. That's one ratio we could have. Another one we could have is A over H. We could have A over H. And we could also have O over A. So O over A. It's getting a little crowded here. Hopefully I can still work. I'll create some nice lines here. Like that. Now notice here on this little triangle over here, if I did this tiny little triangle, the opposite is 3 over 5. So for this one over here, it would be 3 over 5. And if I did the big one, it would be the opposite over 10, which is 6 over 10. And if you see, this can be reduced to 3 over 5. So it's the same ratio. So that's exactly the same ratio. And what they found is that if you had the same angle and you had any right angle triangle, the ratio of the opposite to the hypotenuse would always be the same for that angle, for a specific angle. So they said, let's call these certain definitions. Later on, we started calling them trig definitions, and we gave them special names. I'm just going to create a little bit of room to be able to write those down, so I'm going to erase this part right here. So here I rewrote the ratio. the opposite side over the hypotenuse. That's one of the ratios for this angle. Of course, if we were using this angle, this would be the opposite, but we're specifically referring to this angle here. The adjacent, that's a small a. Here I used a big A. Over the hypotenuse is another ratio. So those are the three ratios. We could, of course, invert the ratio, make it A over O. We'll do that in another section. Let's just work on these basics here. Each of these have a certain meaning, or we've given them a definition. What we do is we're calling this the sine of angle theta. That's the opposite over hypotenuse. And this one here, the blue one, we call the cosine of angle theta. And this pink one here, we call the tangent of angle theta. We actually have a shortened form for each of those. I'm going to write that in here. That would just be sine theta. We drop the E. We still pronounce it sine. We pronounce these two the same. Sometimes people will call this sin instead of sine. Don't be surprised if somebody does that. And this here is cosine theta. Some people might just pronounce that cos theta. And this one here, tan theta or tangent theta. People will use either one for that. So those are the three basic trig definitions. Now you might say, well, that's pretty complicated. How do I remember that? There's a system out there that's in pretty common use to help memorize this. I'm just going to repeat that. It's not one that I invented, but just think of this. The first letter in this is S, and then the first letter up here is O, and the first letter and the letter down there is H. So over here, the first letter in this in cosine is C. The first letter here is A on the top, and then H in the bottom. And then the last part here is just the same, T, and then an O, and then an A. Some people find this very helpful to remember SOH CAH TOA. SOH CAH TOA, 3 words, or if you bump your foot, SOH CAH TOA. If that helps you to remember this, so say S, and then O on the top, H in the bottom. Cosine is equal to A on the top, H in the bottom. Tangent is equal to O on the top, H in the bottom. There's just one more way that you can look at this, especially with the tangent function. If you realize these two seem to be related, well, let's take a look at this. What if we could take the sine function and divide it by the cosine function of the angle? Remember, the sine function is defined this way. Let me just put some equal signs in there. O over H, O over H. And this one is defined as A over H. And if we divide those two, if you take this fraction and divide by this one, remember to divide fractions, you flip and multiply. So that's going to be O over H times, flip this, H over A. These H's will cancel, leaving us with O over A. So notice that is the same definition we've given for the tangent. So another definition for the tangent is that this is also equal to the sine over the cosine. So this is equal to sine theta over cosine theta. I have prepared a sheet for you that explains all these, has these all out in detail. It's on my website, physicsdoctor.com. You can go and download it there for free. But I think it's really important that you memorize these definitions. There's not a lot of things that I'm going to ask you to memorize, but this is very important. If you can use this system here, that's great. But one of the reasons we have you do problems over and over again, many different problems, is that you get it into your brain. What happens is if you do something over and over with your brain, it's like in hockey, learning how to shoot a slap shot, or in baseball, hitting a ball, or being able to dance in the right way. All those things require repetitive motion. That repetitive motion actually creates new pathways in your brain and makes your brain sort of bigger on the inside. It's like learning a new language. Your brain actually gets bigger on the inside as you learn new things. So memorizing new things like this isn't going to harm you. It's actually going to make you smarter overall. Won't limit the amount of space in your brain. It actually increases it. So it's good to memorize a couple of things. The rest of the functions that we're going to need to do, we're probably going to be able to develop very naturally for you. It won't require as much memorization. But this basic stuff, these things right here, you're going to need to get into your mind as fast as possible. So again, I have a page for you to download. I hope this was helpful. Check out the next video. We're going to continue on with this series. Bye-bye.